Good afternoon, ladies and gentlemen. Nice to see you here today. After some break, we will do next Docker Meetup in Warsaw. This evening we have two presentations. We had to change the order because the other prelegent will be here a little bit later. So we will start from Arnaud. He will be talking about BuildKit. I've seen a presentation about that in June. It was very nice, so I think it will be very interesting for you. And one thing that I would like to mention before the meetup will start, this time we have almost certain date of the next meetup, so it will be the 15th of November. Please save the date. And what to be said more. So, of course, we are very happy that we are here. Thank you to Bon Privat. I hope I told it the correct way. And let's meet Arnaud.
All right, thanks. So, hi everyone. So I'm going to tell you a bit about Docker Build and BuildKit. First thing, don't hesitate to interrupt me if you have any questions or any remarks or if I'm talking too fast. Just a quick show of hand. Who knows about BuildKit already? I've heard about it? Good, okay, perfect. So I'm going to start with the mandatory introduction. So my name is Arnaud Porterie. I spam pretty much anywhere on the internet, GitHub, Twitter, etc. I'm the VP Engineering at Bon Privé. So Bon Privé is an e-commerce website that you probably never heard of here in Poland, but is one of the top 3 e-commerce websites in Europe. We do have offices in Warsaw. This is our office in Warsaw, and yes, we are hiring. Before that, I was a senior engineering manager at Docker Inc., so Docker the company. So I was both a maintainer of the Docker open source project and the engineering manager for what we call the engine team, which is basically the core team managing the Docker engine. So I have been running most of the open source activity and the open source work at Docker for 3 years, from 2014 to 2017. So basically joined the company when it was 30 people and left when it was 300 people. And that's it. And I'm still today a member of the Moby project technical steering committee, which is basically the overarching open source project behind the open source bits of Docker. Anyway, that being said, so why am I going to talk to you about Docker Build and about BuildKit? Well, first of all, it's one of my favorite features of Docker. I don't know in the room if people are more ops or more devs. I'm definitely on the developer side of things. And Docker Build for me was really a game changer when I discovered it in 2014. It's basically what made the switch for me to understanding Docker as a huge potential for developers and as a way to really bring a game-breaking change in how we were doing development locally for us. It's a feature that is heavily relied on. It is extremely important for developers. This is the one that is the main building block and the main piece of the workflow for most developers. And I think it heavily participated in the Docker adoption. Without Docker Build, I don't think we would be using Docker as much as we are today because it would be kind of restricted to a deployment tool more than to a developer tool. The other reason why I really like the whole story behind Docker Build and the reason I wanted to talk about this today is because I think there's a lot of engineering lessons to take from there. First, it's really interesting how the MVP of this feature turned out to be a game changer. The first version of the Docker file and what you know of the Docker file and Docker Build is it's not super fancy. I mean, it's not very over-engineered. It's not really thought out, but it was so important to so many people that it just worked. And then there's a lot of lessons about how you can actually evolve a feature like this one, which is used by millions of people, in a way that is backward compatible and in a way that improves things without breaking things. And this is honestly a huge challenge when we're talking about a scale like Docker. So let's talk a bit about Docker Build. So I'm assuming you all know what this is about, but the purpose of Docker Build is to produce a Docker image from a Docker file in a repeatable way. This is a very simple example of a Docker file, so plain text, a couple of instructions, Nothing fancy, again, I mean, it doesn't look pretty, it's not super smart, it doesn't have a lot of features of typical programming languages. It's more of a markup language that allows you to describe how you want to build your application. So really nothing fancy, but I really insist on the repeatable way because this is one of the major founding building blocks of Docker. It's about saying that with this Docker file in my repository, anyone in this room can build my application in a deterministic way. So we don't have to install prerequisites. We don't have to talk about what's on your host, what's on mine. If it works on my machine using Docker, it should work on yours. This is more easily said than done. It means that there's a lot of assumption that have to be baked into Docker build so that this guarantee is actually provided to the users. And it's one of the things that made Docker build so difficult to evolve and to maintain. So the original design of Docker build, this is basically the major workflow. So there's 3 steps: the context, the Docker file, and the image. The context is basically everything that lives on your laptop or on your development host when you are building the app. So it comprises your sources, your anything that is required to build the app, essentially. And when you do Docker build, so using the Docker build command or the /build API endpoint, what happens is that the Docker client takes all of this context, wraps it up in a tarball, sends it up to the daemon. And this is what we call the build context. Then in the middle, you're going to have the Docker file. So this is the part where the Docker daemon takes the Docker file line by line and executes the instructions in order. Each instruction is producing a layer in the final image. So this is why when you inspect the content of an image, you see all those layers. And those layers are kept as cache for ulterior builds, meaning that if your Docker file is written in a smart way, where, for example, the copying of the source happened at the very end, if you change the source, Docker doesn't have to rebuild the whole thing. It's going to take the cache for all the first lines. It's only going to copy the new source and do the build. And finally, an image is generated and tagged as requested by the client. The problem is with this design, it has lots of shortcomings. The first one, and probably the most important one, is that performance-wise, it's super suboptimal. I mentioned it, the context is sent at every build invocation. So because there's this kind of client-server architecture to Docker, the daemon, when it builds, doesn't know what has changed. So we have to work with the assumption that anything may have changed, which is why when you start a Docker build operation, the first line is always going to be sending context. And this can take some time if the application is big enough. So on a big repository such as Docker itself, the context is dozens of megabytes, potentially hundreds of megabytes. This is a big thing to actually tar, send over to the daemon, just to check that potentially nothing has changed. So this is a waste. The other thing is that the Docker file, by construction, is sequential in nature. Like there's, in a Docker file, there's no such thing as reusing bits of another Docker file. There's no such thing as saying that this is one thing that you have to do once, and then you can do the rest only when the code changes. When you read the Docker file, basically, this is exactly what the daemon does. It reads the Docker file line by line and executes. There's no way to parallelize. There's no way to be smarter about the way we evaluate. This is kind of a problem, and it's especially a problem if we would like to improve Docker build performance. Another shortcoming is the cache management is super impractical. So as users, I guess it's always been a bit confusing where the line is drawn between build cache and images. In the very early design, the reason why we used images as build cache is because it was practical. Like images already existed, and it was an easy way to say, okay, we need a build cache, let's reuse layers and images. Problem is that it's for the user, it's super confusing. What's an image, what's cache, what's the line? What happens if I remove my images? Do I kill my cache? It's very impractical, and worse than this, it actually comes with it has come in the past with security flaws. Also raises the question, how do I reclaim my space in terms of build cache? Can I share my build cache with other hosts? So definitely not a great design. And finally, difficulty to evolve. And so this is, from my perspective as a former Docker maintainer, this was the major problem. The syntax is tied to a particular daemon version. Because the interpretation of the Docker file lives inside the daemon, if you want to ship an evolution of the Docker file, you have to upgrade the daemon. But if you take the repository of somebody who's using a newer feature that is not yet in your daemon, it won't build. So that's obviously a problem. The other thing is that there's a lot of opinions and feature requests about the Docker file. Like everybody wants something to be added in the Docker file. Just for the sense of scale, at the peak of the activity of the open source project, when it was really growing, we were receiving about 200 pull requests every week. So that's 200 people sending you a patch for a feature or for a bug request. And you have no idea how many of those features were actually related to the Docker file. So somebody thinking like, like the Docker file, we really need an if then else. We really need include. We need a for loop. We need variables. We need whatever. Everybody wanted to make this into a full-fledged programming language. And this was extremely hard to decide. The problem is that there's good sense in all those ideas about adding features to the Docker file, but at any time we were evaluating this kind of feature request, there was an actually real risk of accepting the feature that would make us break the repeatability assumption. One example I can give is the mounts. This actually originated from Red Hat. They wanted to have the ability to mount some local files into the build container. Why? Because when you're building on a RHEL environment, you have a license file on the disk, and you want to be able to use that to do some package installs using your RHEL license inside the build container. Problem is, if you do that, the build becomes dependent on your host. And if we accept this kind of feature, then it means that the build is not repeatable anymore. We break this kind of guarantees. So this was really, really problematic to the point where around 3 years ago, we decided just to freeze the syntax and refuse anything that dealt with the Dockerfile syntax because it was just too hard to evolve. And really the problem behind this is what I put in the last slide. It's essentially the Dockerfile syntax is the API. This is what the original design is. So you give it the context, you give the daemon the Docker file is executed, but this is the API. There's no other way to express anything about the build. So this is all those things that BuildKit is meant to address. So BuildKit, this comes from the README. BuildKit is a toolkit for converting source code to build artifacts in an efficient, expressive, and repeatable manner. It's not drastically different from what you guys know of Docker build. I would say the major difference is that it's not baked into Docker. As you can see from this sentence, it's about converting source code into build artifacts. So Docker image is just one possible build artifact. And lastly, the main author is a guy named Tony Stiggy, and I cannot overstate how smart this guy is. He's a Docker maintainer, and he is the brain behind BuildKit, essentially. So what's super interesting with BuildKit, and vastly different from how Docker build is built today, is that it uses a binary intermediary format called the LLB. So LLB means low-level builder, whatever, low-level builder representation or something. It is to Dockerfile, but the LLVM IR is to C. So if you're familiar with LLVM, it's the idea of saying that whatever the language you're using, you're going to compile down to a common representation, and this one is going to be interpreted. So that's what LLVM does. Whatever you compile from is actually going to target an intermediary representation called the LLVM IR, and this is what the compiler actually uses. Same pattern is used for BuildKit. You take whatever input, whatever readable format is used as the developer to describe the build, you compile this down to LLB, and this is what is actually taken by BuildKit as an input. And we'll see in the demos and in the ulterior explanations how this is actually really a game changer, because as you can see on this diagram that I draw, you can have multiple versions of the Docker file compiled down to LLB. You can also have something which is entirely different from the Docker file compiled down to the LLB. So really, if we go back at the overall process and the design overview, the three steps here are front-end, LLB, and BuildKit. So the front-end, its role is to convert arbitrary input. So typically, this is going to be a human-readable description of a build operation into a dependency graph expressed as LLB. So take the Docker file, for example, the human-readable text, line by line, converting to something which is a binary representation of the build, and this becomes the LLB. The LLB representation, it captures all the necessary steps to produce the desired build artifact. So everything is captured by the LLB. You don't need the Docker file anymore once it's translated and compiled down to LLB. And because it is a content addressable directed or acyclic graph, it allows for efficient caching and parallelization because you know all the steps that comprise the build operation, you know the different paths, you know the dependencies of one node to the next, and that means that you can start doing smart things. You can start looking at whether this node can be run in parallel to this other node. You can look into whether this path is actually already cached and you don't have to evaluate it anymore. This is where the smart stuff in terms of backend starts to be interesting. And at the very end, you have BuildKit, so takes in the LLB. What's interesting compared to the former approach is that you don't have to send the context beforehand. BuildKit only takes LLB as input, and once it evaluates the LLB and sees that some files are actually required to run the build operation, it's going to request them back to the client. So no more operation about tarballing the whole thing and sending it over to the daemon. You evaluate the LLB, you see what's actually requested. For example, like I'm adding a file in the container file system. Okay, client, send me that file so that I can add it. And everything is lazy, essentially. And then the build artifact is going to be outputted using the specified exporter. So for example, as a Docker image, but that's just really one possibility. BuildKit ultimately is a build engine more than it is specifically tied to Docker. So there's several ways to use BuildKit. The first one is to use it entirely standalone. It doesn't require Docker. It can run entirely on its own. It has a standalone daemon called BuildKit-D, very original, and it depends on only on RunC for execution. BuildKit-D has an API which is exposed over gRPC, and there's a user-friendly CLI that you can use to contact the daemon. The CLI is called BuildCTL. And for the next demos, what I'm going to do, because I'm using a Mac here, is that I have the daemon running in Docker for Mac, because the daemon doesn't run on Mac, obviously. But BuildCTL, however, builds perfectly on Mac, so I can use BuildCTL locally, talk over gRPC to the daemon running on Docker for Mac. And with that, I think we can go over a demo of BuildKit-D and BuildCTL. So we're going to start. Let me check if everything is clean here. Everything is certainly slow. Come on already. Okay, so no containers are running, just a couple images. So what we're going to do is start by actually running the BuildKit daemon. So as I said, you could run it entirely independently on a Linux host. I'm going to run it in Docker because I'm using a Mac, so I have Docker for Mac. So what do we need here? Well, first we're going to call the container BuildKit. We're going to expose it over port 1234. Because it's running in a container, it's going to need the privileges. However, if you're running BuildKit-D, bigger, it's already quite big. Is it good here? Everybody can see? Okay. It's going to need privileged, but actually, if you run BuildKit-D standalone on the host, you don't need, it doesn't require root privileges. Only RunC behind the hood requires root privileges. So we'll call it BuildKit. BuildKit. The image I'm going to use is Tonis's BuildKit. And I am going to have to specify the address it's going to listen on. So I'm just going to say listen on any address on port 1234. And because I always want to double check, yes, I didn't forget anything. So let's run BuildKit. Okay. So BuildKit is now running. I have a daemon running. So let's look on the command line side of things. So BuildCTL is the CLI to this. So BuildCTL is super simple CLI. It doesn't have a lot of commands. It has things to check disk usage, to clean up the build cache, the build, which is the main entry point. Basically, it's the one thing that we care about the most, debug utilities. So here I'm just going to specify where the BuildKit host actually is. You can do this for an environment variable, kind of like Docker host. You have a BuildKit host. I'm just putting in the command line to be explicit for the demos. Actually, that's the default, so I shouldn't have to specify it, but anyway. And in terms of debugging, you can see, for example, that I can check the number of workers. So worker in the concept of BuildKit is pretty much something that can execute build operations. It is interesting because you can see that the platform here is Linux AMD64, of course, because BuildKit is running in a VM in Docker for Mac. You can actually have multiple workers. This is a new feature of BuildKit. You could imagine having, for example, several VMs on your host and binding them to BuildKit in a way that BuildKit has a Linux worker, a Windows worker, and a ARM worker. And with that, you can use BuildKit in a single invocation to generate, for example, multi-platform images, which is kind of interesting. I'm not going to demo this because it's honestly super complicated. But if you think about, for example, Docker official images, things like Redis, which are built for tons of architectures and for different systems, this means that now they have the ability to generate these images with a single host, which is pretty killer. So here we're going to do one simple build. So here I'm in a very simple Go application. It has a very simple Docker file that I showed in the beginning. It's really not smart. It uses a Golang base image based on Alpine itself. Runs a Go build, really nothing fancy. So to build this, what I'm going to do is buildctl build, and I'm going to show you what build expects before moving further. So build has a lot of interesting options. Most importantly, it asks for a front end, because BuildKit is not built with the assumption that I'm going to use a Docker file. It can actually use pretty much anything. What BuildKit care about is LLB. So I need to provide the thing that is actually going to translate whatever build format I use to the LLB. So in this case, what I have is a Docker file. So my front end is going to be called Dockerfile v0. This is basically the baseline of Dockerfile. There's more flavors that are being implemented now. What I'm going to do is next is to provide my context, because although the context is not going to be sent from the very beginning to the BuildKit daemon, because it's going to wait lazily to see what's actually needed for the build before requesting for them, I still need to provide basically a directory where those files are going to be found later on. So this is expressed with the --local. So --local. So in this case, what I do is context is local is here, and my Docker file can also be found here. And I think that's pretty much it, actually. So let's try this and see what it does. So this is the output of BuildKit. So it's a bit different than Docker build as you know it. Not vastly different. What it does is that it shows you the timing. It shows you all the list of operations that it's doing. One thing which is interesting, which you can see in white, all the things that it's actually doing in parallel. Everything in blue is finished, but everything in white is actually happening. So it's not the case here anymore, but you could see earlier that, for example, pulling the first image and then packing the other image was actually happening in parallel. And this is very interesting, because what it means is that I haven't changed my app, I haven't changed my Docker file, but because I'm using BuildKit to build, I'm already benefiting from some of the performance improvements that it has added. It's already using my Docker file as it existed before, but doing things in parallel and saving times. So okay, the build is finished. So what happens now if I do Docker images? The image is not there. Of course it's not there, because BuildKit is running in a container. It doesn't know anything about my daemon. I never told him to actually export my image to the Docker daemon. So just for the sake of the example, if I wanted to do that, I need to specify the exporter. So basically tell BuildKit, this is how I want to produce my output. It doesn't have to be a Docker image. It can be something else. It can be a tarball. It can be a VM image, potentially. It can be a lot of different things. In this case, I'm gonna ask for a Docker image. So the exporter is Docker. I can specify the name I want to give to this image. So I'm just going to do it for the sake of clarity. And because this image is going to be produced as a standard output, I'm going to pipe it into Docker load. So doing it again, what's interesting here, as you can see, is that the context was not sent anymore. I started the build. It's only transferred just a couple bytes, my Docker file and my Docker ignore file. It actually didn't send the code. Like the code is a couple megabytes. It didn't have to send it because everything is cached. And because everything in BuildKit is lazy, it didn't even require the client to send the files over. So now it generated an image that it exported as a Docker image, and you can see that now it's appearing in my daemon, and I can use it like any other image. So that's one first example of using BuildKit and BuildKit-D and BuildKit CTL. It does a couple other nice things. So I'm gonna kill it now. And what I'm going to do is show you one thing that I think is really cool. BuildKit has a built-in support for open tracing. So if you're not familiar with open tracing, it's basically an open standard to trace messages and flows into an application. So what I'm going to do is I'm going to start a Jaeger container. This is not super interesting, basically. It's just a daemon that implements the open tracing protocol so that I can send metrics and show you what it does in practice. I'm going to start BuildKit again, but instead of using the exact same command line, I'm actually going to provide it this time with the information so that it can trace to Jaeger. So this goes through an environment variable called Jaeger trace. I'm obviously going to misspell this one, but we'll see. So Jaeger trace, I'm going to trace to Jaeger. The port is 6831. I'm going to link it to the Jaeger container so that they can talk. So some of you may think that I'm very old school using links instead of Docker networks, but the truth is I'm old school on this. I just think links are easier. Panic. Okay, so that's a bug report. So yeah, I misspelled Jaeger, of course. Yes. Let's try this another time. All right, so BuildKit is started. The daemon is started again. This time it knows about Jaeger and is going to trace everything that it actually does. I'm not going to build the same app. I'm going to pick something bigger so that it's more interesting in terms of traces. I'm going to build Moby itself, so basically the core of the Docker engine. This project has a Docker file, of course. If you never looked into the Docker source, the Docker file is really horrendous. It's huge. The Docker file of Docker itself is really, really huge because it has tons of dependencies. So it's something that typically takes 10 minutes to build with lots of different operations. So that's a good example of a complex Docker file that we can use. And we're going to try and build it with BuildKit. So the first thing is I'm going to just check if Jaeger is actually running. Make sure that this is looking good. Okay, so Jaeger is running. Right now there's no trace, no services, so let's do it. So building Docker with BuildCTL. So BuildCTL, as earlier, pointing it to the right BuildKit daemon. 1, 2, 3, 4. Build. Front end. What I have here is a Docker file. Context is this directory. Docker file is found in the same directory. Am I forgetting anything? Yes, I'm forgetting also to inform the BuildCTL that I have a Jaeger instance going and that I want it to trace. So for this, I'm going to just export Jaeger trace equals what was the port of this again? Sorry, I have it in my notes. 6831. Okay, so let's try this build. So this is the build running. So again, Docker source is huge, but the context was actually very minimal. We only sent over the Docker file and the Docker ignore file. And this is all the things happening in parallel now. It's pulling layers in parallel, and it's starting to execute the LLB. Now if I look into Jaeger, what do I see here? So you can see that there's traces coming up, traces from BuildCTL, for example. So let's find it. And this is my build operation running. So this is really cool because what's happening here is that I have my build operation running. And again, I haven't changed the code. This is regular Docker using its regular Docker file as you would find it right now on GitHub. Nothing was modified. But the fact that I'm using BuildKit, I'm already benefiting from the performance improvement of here, the parallelization, and the new features such as having open tracing. And if I refresh this, you can see that my build is ongoing, and I can actually see how my build time is spent. So as a developer working on a big app, this is absolutely crucial because it means that I can actually investigate where my build is spending time, optimizing my build operations. Here there's a lot of HTTP gets because of course we're pulling all the dependent layers, so pulling images from Docker Hub, pulling a tons of things, also requesting back and forth with the client to start sending files over. And then we're going into the whole very, very complex build process of Docker. But again, you can see that there's basically a dozen operations running in parallel right now. We are at 14 build steps over 59, with a couple things happening in parallel, different dependencies being installed at the same time simultaneously. And again, all those operations being traced and sent to Jaeger so that I can actually inspect what's happening in my build operation. All right. Any questions so far about this? So far, so good? All right.
Is there a limitation of
parallel operations, I don't know what's the limit at this point. To be honest, I don't know how it's implemented in the details, so I don't know if it's using the number of cores, if it's using anything like this, or just parallelizing to its best. I don't know. It's worth checking, definitely. Other questions? Can move on. I'm gonna leave well, actually I'm gonna kill it. I'm just gonna use energy for nothing.
I have a question. So you mentioned that you can have multiple workers bind together. So if you run a complex build like this, can you distribute the load among the workers?
Not at this point. Right now, the concept of a worker in BuildKit is not actually a remote host. It's only a locally available thing that can execute a command. So it's not meant to distribute on a cluster. It's only meant to do cross-compiling, multi-platform builds, and stuff like this. There is an issue right now about supporting Swarm and allowing to build on a cluster. There is a lot of mixed opinions whether this is actually going to be useful or not. Honestly, I don't know myself. I can see how it's going to be interesting, but it raises so many questions, especially in terms of sharing the build cache, that it's hard to say if it's actually going to be a win to distribute the build. But maybe, again, with BuildKit, the good thing is that once you have the LLB, you know everything about what is required for the build operation. So BuildKit could be smart enough to say, like, okay, this build cache is available on this host, so I'm just going to route this build operation here, and this build cache is available on this host, so I can run it there. Really, it depends. I don't know if it's going to be. I don't know if it's going to be a game changer. I don't know if it's going to be a big win. Also, a lot of builds are definitely I/O bound because you're going to pull down a lot of images and stuff like this. So, really depends. All right. So going back to the presentation. So I was there. All right. So, what have we seen? We've seen the user experience of BuildKit D, BuildCTL. I showed you a bit of the new concept and facilities. So, what's a front end? What's an exporter? How is the local context passed? Cache management, I didn't talk about. There's comments for this. So, basically, all the BuildCTL DF and stuff like this. And I showed you the built-in support for open tracing. Now, this was the first way of using BuildKit, but the truth is most people are using Docker and are not going to use BuildKit directly. I should mention, however, that there's a lot of other projects already starting to integrate BuildKit as a facility to do builds. You might know about OpenFaz, which is basically an open source implementation of Lambda or serverless infrastructure. It's already using BuildKit, and I'm guessing that they would be interested in doing things like distributed builds. But there's another way. You can actually use BuildKit embedded in another system, so as a library. And it's actually the case in Docker right now. It's been experimental in Docker 1806, but now with Docker 1809, which is supposed to ship in the upcoming weeks, it's going to be built in as a standalone feature, and it's going to be opt-in, but anybody can use it. So let's look at what it looks like with Docker itself. So which one am I going to use? Let's use the very simple Go application that we looked earlier. What I can do is only on this client side say docker underscore BuildKit equal 1, and then a regular Docker build, Docker build -t, name my thing, dot. So here I'm using regular Docker for Mac as it's available for anyone. I just changed one environment variable and I'm using BuildKit. And I'm benefiting from all the good things that BuildKit has to offer, including, for example, the fact that right now my Docker build is going to be tracing to open tracing. One thing which I can show you is that I can still use First thing I can show you is, of course, that in this case, I don't have to specify anything about exporters or stuff like this. My image is already available as a Docker image. It's just exactly what you would expect. The only thing that is different is the output and the fact that it's using BuildKit under the hood. I can still do a regular Docker build. One thing to notice is that it's not actually going to use my cache from BuildKit because it's not absolutely at all implemented in the same way. But it's always funny to notice that, well, when I do a regular Docker build, starting by sending the context, which in this case of the simple app is already almost 6 megs. I'm going to kill it because it's boring. But when I use it with BuildKit, you can see that nothing is sent anymore. Like here, I haven't made any code change. There's nothing to send, so it's basically instantaneous. And then I talked about different front ends. So I mentioned the fact that one of the key aspects of BuildKit is that it actually supports different front ends compiling down to LLB. Dockerfile, of course, is one of them. But you can imagine using anything else as a front end. You could imagine implementing your Python front end if you want to express your build as a Python script. You could imagine using Lua. You could imagine using pretty much anything. So I'm going to show you one example of this, which was actually, I was discussing with Thomas, the guy who is developing BuildKit in the past few days because I wanted to prepare this talk. And I asked him if he had any example of something that I could use to showcase a different kind of Docker file, something that looks vastly different. And he actually replied to me this morning with something that he developed pretty much yesterday, which is basically support for build packs. So I don't know if you heard of build packs. Build packs is basically the build format for Heroku and for Pivotal Cloud Foundry. So it's an entirely different ecosystem. It's not using Docker images or anything like this. And basically when you have a build pack, so this is a very simple Python app. It's just a hello world. When you have a build pack, it looks like this. You have a manifest.yml that describes how these things are supposed to be run. It's not interesting to understand how these things work. The only thing interesting here in this context is to understand that it's just a different ecosystem than Docker. It's using something different. It's not a Docker file. It has a manifest, and it's using a different build tool. Well, the funny thing is that with BuildKit, I can actually build this into a Docker image. I can say, okay, build CTL. So same thing, using the same BuildKit daemon than before. I'm going to build it. The front end I'm going to use is not Dockerfile. The front end I'm going to use is, how is it called again? Tonis pack, I think. What do I have to specify? So local context is dot. I think that's all I have to specify for this one. And you'll notice that what I specify as a front end is actually a Docker image. This is going to come from Docker Hub. So the really cool thing is that I don't have to install anything. Like the front end itself, the interpreter capable of understanding the build format and translating these to LLB is an image. I'm not sure I got this right. Let me just double check. Front end. Oh yeah, sorry, I missed something here. The front end I need to use is actually a thing called the gateway. And this one is the front end capable of taking any arbitrary Docker images as a front end. So I have to specify that my front end is the gateway, and that the image I actually want to use as an interpreter is Tonestigi pack. And if I run this, invalid value, so sorry, fronted opt source equals Tonestigi pack. Now you have BuildKit running, so what it's doing is that it's actually downloading the pack image from Docker Hub, and this is the front end that it's going to use to take the manifest YAML, which is something that Docker has no idea what's about, same thing for BuildKit, no idea what it's about, but take the image that knows how to interpret the stuff, read the YAML, produce an LLB, and this is what is being sent to BuildKit and executed by BuildKit. So I'm running essentially a build operation and producing a Docker image from something that has nothing to do with a Docker file and nothing to do with a Docker ecosystem in the first place. So I think this is super interesting and really opens up a lot of possibilities, because who knows what people are going to come up with this. Like, there was already experiments of people who were looking into changing the Docker file and replacing the front end with something entirely different. We had people experiment with Lua in the past to describe a build operation. Who knows what people are going to come up with next. But the great thing about it is that the people maintaining Docker don't have to care anymore. They don't have to do anything in the daemon to support it. We're just going to have more people producing front ends that people will be able to install as Docker images and change the realm of possibilities without really upgrading Docker, basically.
So could you repeat the gateway you specified?
So
is the defined definition?
So the gateway, what it does is basically it's a front end that just does a hop to a Docker. It downloads a Docker image and it forwards the messages to a Docker image. So it's not a front end per se, it's just a gateway to a front end implemented as a Docker image.
Okay, and which step did you use to provide the build definition?
Sorry, with what?
Which option you used to provide the build definition?
Yeah, I'll show you. Actually, I'm going to kill it. It doesn't matter. So I specified the front end, and I said this is the gateway. And then there's a front end option command line that allows me to give more options to this front end. And in this case, what I'm giving him is the path to the image that I want to use.
This is the building image, right? The interpreter.
Yes, this image does only one thing. It takes here what is a manifest YAML, so a build pack, and converting it to LLB. So this image is used to compile down the source to the LLB, and then BuildKit takes the LLB as usual and does the build operation as usual. One last thing I want to show you, because apparently I'm already over time. This is using BuildKit and buildctl, but you can actually do this with Docker itself. There's a super weird syntax. But if I take this manifest.yaml and I add hash syntax equal source Tonestigi /pack. Sorry. Docker build, so regular Docker build, I'm going to produce let's say I'm going to produce a test image. I'm not going to use the Docker file. There's no Docker file, so I have to point it to the build file as the manifest YAML, and the context is dot. So running this, of course, I got the syntax wrong. Syntax. Sorry, let me check, because I cannot remember exactly what's the weird syntax on this one. Oh, thank you. Good point. I'm not using BuildKit right now, so I need to say Docker BuildKit 1, and then do the Docker build. And yes, invalid reference format. Damn it. Sorry, I want to show you guys this. So I just need, because it built it over this night, I don't remember the exact syntax. Actually, BuildKit README is supposed to tell me what is the syntax. Damn it. Okay, sorry, I'm not gonna find it apparently. I'm disappointed. I want to show you guys this. I did it earlier. Let me just check if it's a matter of spaces or something like this, but I don't think so. Okay, it doesn't need source in this case. So here what's happening is that I'm doing a regular Docker build. So again, unmodified daemon, Docker build. But because I added a first line to my build source, so basically what could be the Docker file, I can use an entirely different front end because BuildKit takes this first line, understands that it doesn't have to interpret it as a Docker file. It's going to download the image that I specified, use this one as a front end, and then do the build operation. So this means that taking again the example that I had before about the people who wanted to add a lot of features to Docker file. Let's say you want to add if directive to the Docker file. You can actually build your own front end. You can take the Dockerfile front end, you can modify it in the way you want, you can push it as a Docker image on Docker Hub, and you can use this for your builds. You don't have to tell anyone, basically. You can add whatever ugliness you want in your Docker file. The Docker maintainers don't have to care anymore, and that's actually pretty cool. And it means also that, for example, if you're using Red Hat and you want to have mounts in your builds, that's fine. Like, you just take your Docker file as it is, add a first line to say the syntax I'm using is my particular image that actually supports mounts, and that's it. You can run it. And that's, I think, everything that I wanted to show you. Let me go back to the presentation. I'm going to go fast. So what have we seen? So using BuildKit for Docker without any changes, except an environment variable to say export Docker BuildKit equal 1. Using additional front ends as Docker images. I had the answer right here in the slide. Damn it. Using the hash syntax meta directive. And basically benefiting from BuildKit improvements under the hood without installing anything special. Really rapidly on the performance number. So this is numbers while building Moby, so the Docker engine itself. From a clean build, BuildKit is twice faster. So change an environment variable, you get twice the performance as you had before. Sorry? Without cache. This is clean build. With cache up to date, the difference is 7 times. Why? Because we have to send the whole context. So when you have a big app such as Docker, you're sending over dozens and dozens of megabytes. BuildKit just says, no, nothing has changed. It's all right, I'm done. And when you actually do a code change and try to rebuild, so basically, which is a regular developer workflow, it's more than twice faster in this particular example because, again, the context sense doesn't have to happen. Everything is lazy. There's a lot of other things I didn't talk about. It does rootless execution, multi-platform support I mentioned. You can share the build cache, multi-format export. It does automatic storage management with a garbage collector. Anyway, I cannot dive into all the details. I don't have the time, but it's really worth looking into. And if you have any questions about this presentation, about Zone Privé, about Docker, life, the universe, anything, I'm here. Thank you.
Okay, so thank you very much. And now we will have a short break, to 10 minutes break, and then we'll go back with the next presentation. Our host serves something to drink, so please enjoy.